Hello and welcome to this video that goes through the AQA Further Maths Level 2 qualification. This is Specimen Paper 2 and we're going to start by going through questions 11 to 15 in this video. So the first question, question 11, is write a to the power of a half times a to the power of 3 over 2 divided by a cubed to the power of 4 as a single power of a. So first things first is we need to know our indices rules. So the first thing we do is if we've got a to the power of b times a to the power of c, this is the same as a to the power of b plus c. And we can use that to solve our first part of the question, which is the numerator, which is a to the power of a half times a to the power of 3 over 2. And this is equal to a to the power of a half plus 3 over 2, which is equal to a squared. And then we also have two other rules that we have, which is a to the power of b divided by a to the power of c, which is a to the power of b minus c. We're going to use that rule in a second. We also have a to the power of b to the power of c is equal to a to the b times c. So again, useful to know these indices rules off by heart. For the third rule that we came for, we're going to use the denominator, which is a to the power of 3 to the power of 4. So this is equal to a 3 times 4, which is equal to a to the power of 12. So now if we have this set up, we now have a to the power of 2 from our numerator, and our denominator is a to the power of 12. So our last step here is we're going to use the third rule, which states that so it's a squared divided by a to the power of 12, which is equal to a 2 minus 12, which is a to the power of minus 10. So our final answer is a to the power of negative 10. Our next rule we have is question part 12. So it says n is an integer. Prove that n minus 2 squared plus n to 8 minus n is always a multiple of 4. So essentially we're trying to get, the goal of this question is to get 4 in front of some bracket, function, etc. that we don't know yet, but we can find. So essentially we're looking to pull out a factor of 4 at some point. Maybe greater than a 4, etc. But again, 4 is what we're looking for. So how to do this? Well, we need to expand out our bracket here because we're trying to get it all into one equation. So we expand out our first term, so n minus 2 squared. So it's n minus 2, n minus 2. So this is n times n, which is n squared, minus 2n, minus 2n plus 4. So that gives us n squared minus 4n plus 4. And then we've got n times 8 minus n. So it's going to be plus 8n minus n squared. From here, we're then going to collect like terms. So it's n squared minus n squared minus 4n plus 8n plus 4. And this is equal to n squared minus n squared is 0. Minus 4n plus 8n is 4n plus 4. And then from here, we can see that we can take out a factor of 4 from both our terms. So it's 4n plus 1. And from there, you've proven that n minus 2 squared plus n, 8 minus n, is always a multiple of 4 because we factored out a 4 after simplifying. So that is the answer for question 12. For question 13, solve the simultaneous equations y squared equals x plus 3 and y equals 2x. So for here, we start with y squared equals x plus 3 and y equals 2x. The only option you have here is to use the substitution method. You cannot use the subtraction method because of the squared term. So what we want to do is we want to get a like term. For here, I'd say that the easiest thing to do, you have the option of replacing x or y. I would personally probably replace y in this term, because if we could do y squared, we get 4x. So we'll simplify a little bit, So y squared is equal to 2x squared, which is equal to 2 squared, which is 4x squared. So now we know that y squared is equal to 4x squared. We can substitute that into our original equation, and now we get 4x squared is equal to x plus 3. From here, we're then going to rearrange, so it becomes 4x squared minus x minus 3 is equal to 0. Remember, we're trying to trying to solve this equation, so we're trying to find values of x and values of y. From here we end up with a quadratic, which is quite horrible. We've got the 4x squared minus 3. There's two ways that you can do this. You can go and find the quadratic formula and solve it that way. You could use the what I call the Wendy method, which is what we're going to show, or you could complete the square and find the x values. Either of those three methods will work. We're going to use the Wendy method. So the first steps first is to do a times c. Remember, it's ax squared plus bx plus c. So we're going to do 4 times minus 3, which is equal to minus 12. And then we're going to find the factors of minus 12. So that's going to be 1 and minus 12 and minus 1 and 12. That's also going to be 2 and minus 6, or minus 2 and 6. And then we've also got 3 and minus 4 and 4 and minus 3. From here, then we're going to find the factors that make b. So in this case, b is equal to negative 1. So if we add the factors together, we can get our, we can determine if any of them equal minus 1. So 1 minus 12 is going to equal minus 11, and then 12 minus 1 is 11. 2 minus 6 is minus 4, and 6 minus 2 is 4, and 3 minus 4 is minus 1. 4 minus 3 is 1. So our answer here is 3 and minus 4. So from here we're going to substitute it in. So we're going to say it's 4x squared minus 4x plus 3x minus 3 is equal to 0. So we replace our b term with our factors of minus 12. Again, the reason why we do this is because if we add this together we get back our minus x. From here we take the first two terms and the last two terms and we factorize. So for the first term we can take out a common factor of 4 from a numerical value and x from the x's, so we end up with 4x, and this becomes x minus 1. And then for our second one we can take out a common factor of 3, so plus 3 x minus 1. And then from there the first the numbers or the terms in front of the brackets form the first bracket, which is 4x plus 3, and the second bracket is x minus 1. And that gives us our answer, 4x plus 3 and x minus 1. Again, you could have solved it using completing the square, but remember that you want to put it back into brackets. Well, no, actually you don't need to put it back into brackets because we're asking to solve here. So our answer is not yet 4x plus 3 and x minus 1. So here we know that this is equal to 0. So then from here we can say that 4x plus 3 is equal to 0, x minus 1 equals 0. So x equals 1, or we get 4x equals negative 3, and then x is equal to minus 3 over 4. Now we found our x terms, but remember that there is a y term here, so we also need to find the corresponding y term. So we know that y is equal to 2x, so y is equal to 2 times minus 3 over 4, which is equal to minus 6 over 4, and we know that y is equal to 2 times 1, which is equal to 2. So if we simplify minus 6 over 4, this becomes minus 3 over 2. So our answer is going to be x equals minus 3 over 4, y equals minus 3 over 2, or x equals 1 and y equals 2. Remember, this is one of the ways of solving it. We could also have got we could also use the quadratic formula as well, would be the other quicker method. Potentially quicker method depending on if you remember it. And you can use it. You are actually given the quadratic formula in the exam, but again you need to take care that you use the calculator correctly here. Question 14, we're given on the axis below is a circle centre 0, 0 passing through the point 3, 0. So we know that this point here is going to be 0, 0. We know that it passes through, so this is x, so we know that it, and y is 0, so we know it passes through the point 3, 0. The general formula of a circle is x plus a squared plus bracket y plus b squared is equal to r squared. Here a and b are the centre of the circle, as x minus b, and r is equal to the radius. So here we know that a equals 0, b equals 0, so we know that it's just going to become x minus 0 squared plus y minus 0 squared is equal to r squared. We know that the radius is this distance here, which is 3, so it's just going to be 3 squared. So simplifying it becomes x squared plus y squared is equal to 9. The next question we got is decide whether the point 2, 2 is inside or outside the circle. So essentially what we can do is we can use our equation for the circle x squared plus y squared equals 9. If the answer is less than 9, then it's going to be inside the circle. That implies that its distance from the center of the circle is less than what the circumference of the circle is, if it's less than 9. And if it's greater than 9, it's outside the circle. That's just that the distance from the center of the circle to that point is greater than the circumference of the circle. So it'll be somewhere outside. So from here, all we need to do is just plug in our values. We're given an x value, given a y value. So we're given that x equals 2, y equals 2. So x squared plus y squared is equal to 2 squared plus 2 squared, which is 4 plus 4, which is equal to 8. Now, as it is less than 9, it therefore must be inside the circle. So inside the circle, as x squared plus y squared is less than 9. And that will be a good enough justification for your answer here. The circle above is translated so that the image of 3, 0 is 5, 4. Write down the equation of the new circle. So here we can we want to find out first of all what is our translation. So going from 3 to 0, so this is our x to y to 5 to 4. So here we notice that we go from 3 to 5, so we're going plus 2 in x, and then for y we're going plus 4 in y. It's been translated, so we're just going to add plus 2 and plus 4 to our answer. To our circle, our center of the circle. So if we've got 0, 0, we're going to add 2 in x for it to become 2, and we're going to add 4 in y for it to become 2, 4. Our radius will still stay the same. It's been translated, so it's been moved, but the dimension of the circle will still stay the same. So it will still have r will remain as 3. From here, we've now got a new center of the circle, so a is equal to 2 and b is equal to 4. So again, using the equation of circle, x minus a squared plus y minus b squared equals r squared. Our new equation is x minus 2 squared plus y minus 4 squared is equal to 9. And that is your remaining part for 14C. For question 15, a triangle has sides 10.2 centimeters, 6.8 centimeters, and 5.7 centimeters. Work out the area of the triangle. So from here, we know that the triangle has something like 10.2, 6.8, and 5.7, or something like that. It doesn't have to be an accurate drawing, but drawing it out might help you realize what you need to find next. So say that's at 6.8, and that's 5.7 centimeters. So this in itself doesn't help. We can go and check our formula book to see if there's any useful formulas, and we can see that the area of a triangle is given as half AB sine C. So if we go back to our one, we've got half AB sine C. Now notice here that when we want to find the area, we need to find an angle. So to find an angle, we can use the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos A. The reason why we pick this rule is because it uses 3 of the sides but only 1 of the angles, and we can find, having known we've got 3 sides, we can use this equation to find what an angle is, one of the angles will be. So here, if you would like to, you can label some of the sides. So we can say, for example, that this is going to be side A, this is B, and this is C, but you can label any of the sides A, B, C. And let's plug it into our equation. So now we have got 10.2 squared plus 6.8 squared plus 5.7 squared minus 2 times 6.8 times 5.7 cos A. So here we're trying to find this angle here, big A, which is opposite little a. From here we can rearrange our formula, so it becomes 10.2 squared minus 6.8 squared minus 5.7 squared equals minus 2 6.8 times 5.7 cos A, and then we're going to divide that through. Keep your numbers as squared at the minute. Don't simplify it, because you'll find that you'll end up with a very long number that you would probably want to start simplifying, and it's probably not the best idea to do that in case you miss round a number or you shorten it by too much. So from here what you should do is, to get our A, we need to inverse cos both sides. So cos inverse of 10.2 squared minus 6.8 squared minus 5.7 squared divided by minus 2 6.8 5.7 is equal to A. And from here you should plug that into your calculator as is. Ideally, if you're not sure, if you're not comfortable doing that, then here you can obviously find the value for the denominator and the numerator, but I would plug this directly in your calculator using the fraction sign, so you're putting it in a fractional form so that you can find it easier to sub in. So if you plug this in and find cos inverse, you should get an angle of big A of 109.056 degrees. From here we then can use this to find the area. So we know that the area is equal to half AB sine big C. Again, the numbers don't matter if the letters don't matter compared to this, but here if you wanted to, we're going to use half BC sine big A instead of using those letters. But again, it doesn't really matter. Hopefully you're at the stage where the letters you can work out what to plug in. So here it's going to be half B times C, which is 6.8 times 5.7, and then sine 109.056. Plugging this into your calculator, you should get an answer of half times 6.8 times 5.7 times sine 109.056, which is equal to 18.318. So here we could say that our answer is simply going to be equal to 18.3. That's a reasonable sum. So keep it to 3. Here we've got to 1 decimal place in our question, so we can write it as 18.3 to match what our question was putting in. Wouldn't simplify it anymore. You could write 18.32 or 18.318. That's perfectly fine. Okay, that's the end of these questions for this video. If you have any further questions, please let me know.